Okay, so it's facing the correct direction. Now let's do a section view to see which of the components penetrates both sides. Turn to turn on our bottom plates. To definitely penetrate inside the support plates. Also, I don't want to make a cutout in the support plate because the support plate is already too thin. So making some cutout there will still reduce the strength of the we will further reduce the strength of the support plate because it's already thin. So I'm going to bring the support pillar down and let it penetrate the bottom plates where I make the cutouts in the bottom plates. So we can go over here to edit the joints on the Z offsets. Since it's facing that direction, it should be -10 because the distance, remember, the distance calculated was 126 and the support pillar we selected was 136. So that's why we are moving down a distance of 10. So you have that fitted in like that. Yes, you can turn off the section view and do the remaining support pillars. Then let's go down to head back our bottom plates. Hit our bottom plates now. Go back to support pillar uh, 50, 136. From that, we go over to edit the joints. Of course, the Z is facing that direction, so I go -10. Okay, so come back when I'm done with all the support pillars and continue from there. So I'm done creating all the support pillars for the node. Next is I'm going to create the cutters for the bottom plates. So I go back to my bottom plates, turn on my bottom plates, then move down. I can hide all the support pillars for now. I'll hide. I think I still need to hide the bottom plates again to pick the sketch points. So to move up to bottom plates. Solid or E for extrude. Now select all the cycles, 50 cycles we created. Make sure the points are completely selected. Yes. Uh, uh, is supposed to be selected. No, include selected 21. Let's see, make sure we selected everything. Mm, yeah, I think everything was selected. So we'll go a distance of -10 and turn on the bottom plate. Yes, it's a cut operation. Okay. Now we have that cut, we have the cutouts, and now can hide the sketch. Can just see what we created. Now can go over and turn on the support plate again. Turn on the support pillars. I'm going to say uh, when now we can quick, see how it fits in your, can do a quick session view to make sure that it's not interfering. And the cutout was, yeah, you can see now there are no interference. I didn't move this downward, so I will correct that real quick. I didn't move it downward, so I think is the well, so -10. Okay. Yeah, so now you have all the plates, all the support pillars fitted in the correct position. So now the next thing I'm going to do is to create the screws that we hold the support pillar in place. So we have to hide the bottom plate, move over to the bottom plate, and calculate the diameter of screw in it. And hide the bottom plates. We can turn off the session view as well. Uh, Inside different specs as 14 mm. So I think we need a 14 mm screw. Let me turn my bottom plate back. So we need a 14 mm screw, but first I'm going to project the screw points onto the back of the bottom plate. So this is the back of the bottom plate. You can create a sketch there, hide the bottom plate there. Before project all those points, projected all the points. So I go back to turn on my to turn back on our bottom plate, our can finish sketch and see the exact distance we need. I need to hide the sketch first. That's the minimum screw distance we need. Cover this plane was 46 mm. Uh, something think it's way more than that because let's see how thick is the, yeah, it's actually correct. 46 mm. So we need something that's above 46 mm. So now we've projected the points. We can go back to our utilities and collect the screen we need. Can go for 8 sets. There are 14 of there are 16 support pillars, so it means we'll go for 2 sets. Just I have to select this properly to make sure I don't select somewhere 2 times. Let me cancel that and start again. Have to concentrate on the selection to make sure I don't end up selecting the same 2 points. So let me select these 4 first. Three. I did 3 points there. And 1, 2, 3, 4, 1, 1, Yeah, that's it. One thing we forgot to do is to check the diameter of screw we need. Escape my mind. So for TMM, I didn't write it down initially. Anyway, for TMM and greater than 46 mm for the length. So yes, we have to start again. We started the points. Two, three, four, then total and 14. Since the minimum distance we need is 46 mm, can go for 60. Thread length we must go for something uh, above 10 mm. And you can wait for it to do its computation. We're going to do for the other side as well. So I'm done fitting all these screws to their positions. So now we'll do a section, a section view to just see how the screw engages the components. So go down, you and see from there. So it's how you hold the support pillars in place. So now we need to go back here, open all the open all the socketed screw to get our cut bodies. Then we combine it with the bottom plates. So let's do that. Now finish opening all of them. Let me select the cut bodies. So yes, I'm supposed to be text two bodies in number. No need to. So it's supposed to be a combined operation. Supposed to be a cut operation, not a combined operation. Made that mistake again. So wait, once I'm done, we edit it. So go back here, edit visual. It is supposed to be a cut operation. So now we've got that. So now we are just almost done with the mode. Just one remaining step, one last step. I want to turn on the retainer plate and the injector plate just so you see how everything looks like. You can see that clearance we give for the support pillar. So this one side, I moved on with the bottom side. So next thing we're going to do is to add the eye hooks, the lifting hooks for the mold. So it's more advisable to put it here because of the ease of the like when they are losing the mold or want to carry out maintenance, they can easily flip it over, like they want to change the pipe locks. So it's easier for them to flip it over and rest it like this without it grounding anything. So I'm going to keep the iFoods here on this side where there's nothing because you have the filling line on this side, filling line on this side. So they can rest it there, they can rest in those positions. So, but we have nothing else to, here's the force to fix the lifting icon. So we have to go back and create our sketch on display. Uh, just, um, wait for the center point. To get the center, the middle of that. Yeah, take this. Yeah, so don't really know the diameter I'll try to be, but just draw a circle at that point. About to utility. So it's easy to select the type of output you need. Just the size they arrange in terms of increasing mass. As the higher the number of the weight of the node. So you can check the catalog to see the amount you need and you can confusion as well. Know the mass of this one as well. Also. So let's go for 4. Components as origin and for mass. We need to know the components. Let's go down. Right, drag it out. Now the right thing to do is to select the mass box, check the weight of the mode, the total weight of the mode box. For these demo purposes, I'm not going to go through that process. So, but what I just feel this is too small. So let me remove it. We just go for the biggest one. So let's go back. I will just go for 7. Components are the origin, and for most each results. Now this is the bigger. Okay, right. J for joints. The word there for the displays. Flip to this other side. Okay. Now you can rotate it to and also rotate it so it will become more convenient. To -180. Well, so that should be much more easier to for someone to place a channel. So that's the game. We go back to our upper parts. So hide. Now I go down again to edit this sketch, the same plane. So I'm going to mirror the circle. Select the mirror line. Okay. Now finish sketch. Now we place under I hook on the injection site. So I will set it in. Now components are the origin. Going and for most drag this out. Capture position. Okay, so now let's check the amount the type of screw we need. So that says our diameter is 26.5. So try to give us the minimum amount of screw we need to fit in there. Also now we can bring this to the body. uh, so for this kind of assembly, we're supposed to use a set screws to put them in place. But for now, we don't have set screws for the fasteners. Maybe that will be made available later course. We need something you can screw it from the sides. So, but since we don't have that for now, what we're going to do is to create holes for bending to fit in the set screws. So now, but first, let's add this to the part of our cupboard is it is a long way. It's a long way to be a very long task for me to get it. What I'm going to do is just create selection set from it. Then over to the selection set, put it inside there. Then I'm going to do this one. So we can create this. That becomes one entity. It's like that. So let me turn it back around. How you two items. Now go back to the sketch. Now you can already sketch anyone. So I project these points, this circle, this circle. Okay, you know, since the diameter of your hole there is 26.5. You can also don't know if there is 26 set screen, but you just put that there. 26. And then I can finish sketch. Then it's equals root. I got this one. I got this one. So I can go for minus 20. Okay. Uh, now we can put thread there to indicate to the machinist or manufacturer that there should be a thread there. Come true. Okay. Yeah, done with the mode. Can go ahead. I'll hide this one for now. To hide. I'll go down. after this point, so hold down control, select this one, select this one, select this one. Now, go down here, from here, it's supposed to go down control, every again, if I like this one, go down control, select this one, select this one, select this one, select this one, keep holding down control, select this one, now, I hold on shift, like, move down, 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 down. Okay, this point, right click, create selection sets. When that is created, look up. So, we have 176 components. If I show height, everything disappears. This we selected everything correctly. Let's go again, show height. Now I can go down to relationships. From here, go down sheets. The last component we join to us the written output. So make sure select the last one from the carry over for dump it here. So we have about the last one. This one. To take it up here, drag it here. Yeah. And also so supposed to be on the first selection set. Down here. The last one, drag it up. Supposed to be there. And now I should have everything. Everything is supposed to be up here. So now you're done. Can turn on this one. The height. Turn on this one. So and pick a look at the mode. So now we are done, but there's still some if you wish to continue, you can still do some finishing operations. Like you see all these sharp edges that are like this, they can't be machinable. So based on the machine spec of the node manufacturer and so on, you can add chamfers and figures and other things to the all the mode plates if you wish, and also all these glucose we created, you can add your insert your thread feature needs. So those are the finishing operations you going to do, but this is where we are stopping. So since we are done, you can go over to creating our bill of material. So to create your bill of material, you move over to utilities. You click on BOM. So you wait for it to finish doing the processing. So it sends you a message. Please ensure you upload the Excel sheets for this current projects if you have previously uploaded it. So if you have created BOM initially or before on this project and the Excel sheet is open, so you have to close that. But it's not open, it's closed. So you can go ahead with OK and wait for it to finish creating the BOM. So you can see BOM was successfully created. Check the AIG module that. So move over there, check our documents. So you can search for AIG. So these are AIG modules that available. So created a DUSTPAN mode. So we can double click to open that. You can see our bill of material have been created. So these are the information we put in initially, and you can see all our components were created. So now you can export this to any format you like I said, this will be available on GrabCAD just immediately after finish the design. So this will also be available on both text format and the Fusion 360 format. So we put the link in the comments and the description so you can go ahead and download it and see, check it out for yourself. Okay, so thank you for following me and don't forget to like and subscribe.